Today we're going to take a look at transformations of functions. So in the last section we looked at families of functions, and we actually could call what we're doing today also families of functions. What we're going to look at is we're going to look at kind of a different way of interpreting how to do a graph. So I thought about bringing with me some different calculators to explore this idea with you. Who has a graphing calculator with them here in class today? Just raise your hand real quick so I can see kind of who we have. All right, so over here we're pretty good at being able to kind of pair up. Over here, who did? Keely, you did? No. Yes, Keely, Megan, anybody else? Okay, so see if you can find somebody nearby with you that you could pair up with to be able to look at their graph if you don't have one. Okay, their calculator. Everybody have that nearby? Okay, grab somebody, move your desk over. What we're going to do is we're going to start out with exploring how certain changes affect a graph. All right? So as you're looking, your graphs don't have to be significantly large. In fact, I don't really even want you to write any of them down for now. But we're going to sketch 5 different comparison graphs one at a time. So start with the first one. I want you to put in your calculator on line 1 of the y equals, I want you to just put x squared, and you're just going to leave that as x squared the whole time. Okay, so your calculator and y equals is going to say x squared. Do you guys know how to graph this? Can I use one? Okay. One extra. Anybody else need one extra, or are we close to?
Mine's dead.
Yours is dead. I think I still have mine on my. There. Okay. So in y equals on the first piece, make sure you can. Okay. Y equals should say x squared, and then the second one's going to say x plus 2 squared. All right, so y equals is going to say x squared, and y2 is going to say x plus 2 squared. Did you guys get that? Okay, so when you do that, go ahead and grab a pencil, something to sketch with. You don't have to do this super intense but what I want you to do is to sketch the 2 graphs on the same axis. And if you can, label which is which. Maybe you have colors in which to sketch them differently, or just label them. So on the first one, x squared looks like, and again, I'm not looking for super accuracy here, just a sketch is fine. And then x plus 2 squared, so I'll do that in green, and then my x plus 2 squared is going to be in blue. Yes, Alyssa? You bet. Didn't put the x. You have to put clear it out first. Just put x.
Okay, so that.
And then square.
Okay. I'm
There you
doing
go.
that. And then, let's see, it says
And
that.
then window. Just do zoom 6. That'll work. Okay, hang on. You won't have to fix this later. I'm gonna fix this now.
Okay.
It's doing something weird here.
Got my high school calling out the teacher messed with my calculator. And put a bunch of
Complex
symbols.
numbers. Okay, and then my other one looked like this. Agreed? Yeah.
Error syntax for when the graph came up. Like it comes
Okay. Does it look like this on both of them? Okay, so the blue one is the g of x, the second equation. What does it look like happened if you compare the first equation to the second one?
It shifted to the left.
Good. It looks like it went left too. Okay, so we're going to come back to that in a little bit, but that's what it looks like. Agreed? Cool. Let's try the second one. So on the second one, these parentheses are not vitally important, but on y1, you're going to leave it as x squared. On y2, I want you to write down x squared plus 2. Okay? Not x plus 2 squared. That's the first one we did, but x squared plus 2. And if you do that, it should look like this, roughly. Again, I'm sketching. I'm okay with you sketching. What does it look like happened to the graph? It looks like it went up 2. Everybody good with that? Okay, we're going to explore a couple more. Again, you're leaving y1 the same every time. I want you to change y2 to say negative x squared. And if you do that, it should look like this. What does it look like happened to the graph? Did everybody do that? When you graphed it on the second one? Did it look like that? Nobody's saying yes or no. Yeses or no's. Michaela, did it look like that? You don't have a graph. Are you looking with somebody nearby? Somebody help Michaela out. Make sure, Trey, make sure Michaela sees the graph. Can you do that for me? Okay. Can you show it to her? Oh, fantastic. Thanks, man. All right. Those of you who are looking at a graph, did yours do this? Fabulous. So what would you say happened if you were describing this change? Looks like it flipped or reflected, right? That's what it looks like. All right. Now, leave y1 the same, and I want you to change y2 to say 2x squared. If you do, it looks something like, I don't mean to make it look taller, that's not really what I mean, this. Of course, it should look symmetric and mine doesn't, but aside from that. How would you describe what happened? There's a couple of different ways that are both adequate at describing it. Got skinnier is a really good phrase. Does it look like that to you? We tend to talk about it as it's stretched, right? We sort of like took the ends of the graph and we stretched them up so it made it look skinnier, like Karen said. And the last thing I want you to do is I want you to change y2 to have 1/2 x. And if you do that, it should look something like this. How would you describe what happened? Okay, so you're describing it from sort of a horizontal perspective. So if the first one was we sort of stretched it up this way, right, up, this sort of looks like it was stretched sideways. You can also talk about this one as being shrunk or compressed vertically. So if you only want to talk about vertical, which is how we're going to approach it, but if we stretch it vertically, we would be shrinking it vertically. Can you see that sort of a perspective? Right, like the Play-Doh, when you squish the Play-Doh down, it gets flat. Okay, so I'm going to pause a minute for you to get those sketched in. Does everybody have them at this point? I know I'm moving really fast. I'm sorry about that. Okay, we're going to do the same kind of an exercise. This is the last thing we're going to do. You and your partner or partners nearby, I want you to do the same exercise with the function square root of x. Okay? There's one extra one that wasn't here last time. It's this one. We'll talk next class period about why. But the first thing you're going to do is in y1, you're going to write square root of x. And in y2, you're going to write square root of x plus 2. When you do that, you have to make sure that the x plus 2 is in parentheses underneath the square root. At least most of your calculators are going to require it to be done that way. So the square root graph looks something like this. Oops, I want the green. And that's what the second one looked like. How did it change? Well, I don't mean how did it change from the x squared to the square root x. I mean, what's the comparison between my blue and my green graphs? It looked like it did what?
It moved back.
It moved back or left too, right? That's what it looks like. It looks like it moved to the left too. What about if the plus 2 is outside of the x squared? I think it looks something like this. And how would you describe that one? It looks like it moved up to 2, correct? All right, we'll do one pair more and then we'll stop. There's 6 of these and we'll do the other 2 to make 4. Again, leave the x or the y1 the same, square root of x. And if you do that, here's my square root of x graph. And then if you do negative of that, it actually looks like this. And how would you describe what happened? It looks like it flipped down or it reflected down. If you consider the whole graph together, what's the shape? Looks like a side, like a parabola on the side, right? It does. And then let's try putting the negative underneath the square root. If I put the negative underneath the square root, it looks like this. And how would you describe that change? Okay, it did. It still looks like it flipped it, right? Or reflected it, but it reflected it sort of left and right, agreed? Instead of from top down. Still looks like a reflection. All right, we'll pick back up here next time.